Thank you. Thank you for that. Okay. So, so I asked you, what would you do first here to multiply? X times X. Very good. And we know X times X would be X squared. Good. And then what would you do? X times 6, which is 6X. And then what? Negative 2 times X, or negative 2X. And then negative 2 times 6. Very good. Okay. Which would be negative 12. Very good. So that's great. And I know you guys know how to do this. And we get a final answer of X squared plus 4X minus 12. Okay. So what we're doing today is we're saying, hey, if we start here, I want you to go in reverse and back up to get into this form. Okay, and so the question is, well, how do you do that? So I also want to kind of show you what this looks like visually too, because a lot of students don't understand that math isn't just abstract. I'm not good at math. I don't consider myself good at math. I am a hard worker, okay? So when I took algebra, I did what they said. I can follow directions. I can follow a process, but I didn't really have any good understanding of what was happening. Well, my life changed when I saw algebra tiles for the first time, which wasn't until after I started teaching, okay? And then all of a sudden, algebra became this really concrete thing. It is a very visual thing. It has a real understanding, okay? So first of all, I want to show you, way back in elementary school, I bet you played with some manipulatives. Manipulatives? Little objects. You played these before? This represents what number? Positive 4. And if I flip those over, this would be negative 4. Okay? No.
They just gave me a paper and made me solve it.
Yeah, right? So what is positive 3 and a negative 1? 2, because these cancel each other out and you're left with 2, right? Okay, all right. So these are ones. All right, they're unit ones. Okay. This is not 5. You'll notice if I tried to line it up, 5 is probably a good answer, but if I tried to line it up, is it 6? Oh, there's 5. It's not quite, is it? It doesn't quite work, does it? Okay. All right, this represents X. Okay, this is 1X, which means this would be 2 X's. Oh, watch, I'm getting there. What's this? 3 X's. Okay, and if I flip 1 over, that would represent negative X. Okay, and if I said, well, what's 2 X's plus a negative X, you would tell me 1X, because these two cancel each other out and we're left with 1, right? Okay, cool, right? Okay, so then most of math happens in multiplication land. And so you need to go back and think back to elementary school. You were learning your multiplication tables and you had that 12 by 12 multiplication chart. You know what I'm talking about? Okay, you got 1 through 12 on the left and 1 through 12 on the top, right? And if you wanted to say like, I don't know, 6 times 8, then you'd get what? 48, right? Okay. Okay. Well, so you go down and go 6 times 8 and see where they match up, and that would give you 48. And I don't know if you ever thought about it, but how many little boxes fill in that little space? 48.
Really?
48. Okay. Did you ever think about that? It's area. Multiplication is area. So, am I blowing your mind for a second here? Okay. So, logically, right now, you're old enough to think about these things. It's crazy, right? So, if you are on your multiplication chart and you go down to 5 times 5, and you line it up, right? And you would get 25 here, right? Yeah. Well, how many little boxes are there? There's 25. And what shape is it? Square. What's 5 square? What shape is it? Square. Square. Okay. So I'm going to do the same thing. I can take my x and I can multiply it by x. And what is x times x? X. What is this?
Oh, it's x squared.
It's x squared. Does that make sense to you? What shape is that? It's a square, right? Well, not this. It's a square. It's a square, and what length is on the side? X by x, right?
Wait.
Yeah.
The top one is longer, and so is the top side.
No, it's
It's the same. This is the multiplication little symbol right here.
It looks like a square.
Oh, is it just, it doesn't?
Yeah, it looks like a rectangle.
Oh, gotcha. So that'd be, you have to trust me that it's a square. On screen, it's being stretched a little bit. Does that make sense to you? Okay. All right. So, all right. This is real stuff, folks. Okay. So this represents what? X squared. Okay. And then, so this would be
X.
2.
Oh shoot.
2x squared, right? Right? And so, and this would be 3x squared. Does that make sense to you? So I can take and I can represent polynomials using these algebra tiles. And so right here, this is the visual representation of 3x squared plus 2x plus 5. Okay? So every polynomial can be represented visually. Isn't this crazy?
It is.
Okay. So now what I want to do is I'm going to say, hey, look, not only can any polynomial be represented visually, but I can model this. So I can take an x and 2 negatives. That's the, what, length? Okay, there's an x and 2 negatives. You see that?
Yes.
Okay. And then I can multiply it by another x, 1x, and what? 6. 1, 2, 3, 4, 5, 6 positives. All right. And so if we want to multiply this polynomial together, then we need to fill in the area, which would be x times x is x squared. What's an x times a 1? 1x, another x, another x, x. I can still go, yeah? Yeah, okay. All right, keeping going here. Okay.
Another one.
All right. Are you colorblind?
No, it looks like a weird brown.
No, but like, why are we? Is it not brown?
It's like a green.
It's green.
Is it not brown?
I saw it on her hand.
It's green.
Oh,
It's
It's a bad bulb. All right. What?
And the thing is actually square, not rectangle.
Yeah, it's actually a square.
Is it not?
Yeah, it's like green.
I don't get
All right. So I'm filling in this area. I'm filling in this rectangle. When we multiply, multiplication is just finding area. What is a -1 times an x? Negative x. Okay. And again, what's a -1 times that x? Another negative x. All right. And then what's going to go in all these little bits here? So just modeling it. You'll see it. You don't have to do this today.
Oh, I would struggle.
So,
with this.
what's negative times a positive? A negative 1.
Oh.
Negative times positive is negative times positive. And all of these are going to be, they're all going to be negative, aren't they?
Oh, yeah.
Okay.
I didn't get it for a second.
Yeah, that's okay. This is new. It's different. All right, negative times negative, or negative times positive, these are all negatives.
You ran on negative.
All right. Now, I want you to notice what we've created here. I'm getting some more. Hold on. All right. There we go. And how it relates to what you already know how to do algebraically, but maybe you don't quite have a picture in your head. When you look at this, when we multiply x minus 2 times that x plus 6, we get 1x squared plus 6x's plus 2 negative x's, negative 2x's right there, and 12 negatives.
Whoa.
And then, of course, you can combine these. They cancel one another out, and you're left with those 4 x's remaining. Okay? And that's polynomial multiplication. Okay, that's what's really happening when we're multiplying polynomials together. So what we're going to do today is we're going to start with this portion, and basically, we're not going to do it by hand. You're not going to use algebra tiles. But the idea is, if you take what you're given and rearrange it to form a rectangle, when we're factoring, we're finding what is that side on the length and what is that side on the width. Okay, so we're undoing it, doing it backwards. Okay? So what I want to point out is, where did this x squared come from? It came from the first thing times the first thing, right? Okay. And where did this negative 12 come from? The negative 2, the last times the 6, right? Okay. So when I teach factoring, I'm going to simply ask you to say, hey, first times first has to be the first thing. Last times last has to be the last thing. Where does this middle thing come from?
Oh, second.
Noel?
The last and the last added together.
Okay, so okay.
You combine.
It's actually from right here, right? From the 6x and the negative 2x, right? Yeah, and that comes from the outer and inner product. Okay. I call that the rainbow. Do you see the rainbow? You see the rainbow right here? Okay. So I always say first times first has to be the first thing. Last times last is going to be the last thing. And for that middle, you're just going to check the rainbow. It works all the time. Okay? So we're going to do some practicing. Because you don't just have the easy ones today. You're going to do the hard ones. Example 1, factor the expression. These are the easy ones. Factor the expression, also known as double bubble. Double bubble. Factor the expression, double bubble. So when we say factor, I'm always going to say double bubble. Please. You really need the example 1, factor the expression, too. That's how I grade your notes.
I've done it once.
Okay. Factor the expression. Letter a squared plus 12a plus 32. And I'm going to say you want to set up your structure. Set up your double bubble. And then simply ask yourself your unfoiling. So First times first has to be the first thing. What times what is a squared? A times a. And then last times last has to be positive 32. What times what is positive 32?
8 times 4. 16 and 2.
8 times 4, 16 times 2.
It's 8 times.
There's lots of possibilities though, right?
Yeah.
What about negative 8 times negative 4? Is that an option?
Yeah.
Yeah. Okay. There's lots of options, right? You got 32 times 1, right?
Yeah.
Lots of options. Okay. So which one do we want to use?
8 times 4.
8 times 4. Okay, so a positive 8 and a positive 4. And how do you make sure that you did it right?
Distribute.
You can check by distributing. Check the rainbow. Check the rainbow. A times 4 is 4a.
4A.
8 times a,
A squared.
8a.
Oh.
And 8a plus 4a is 12a. So we did it correctly.
Yeah.
Every time. First times first, last times last, check the rainbow. All right. Let's try letter B.
Letter B.
Y squared minus 10y minus 24. Double bubble. First times first has to be the first thing. What times what is y squared? Y times y. Very good. Now, last times last has to be negative 24. What times what is negative 24?
Negative 6 times 4.
Negative 6 times 4.
Negative 12 plus 2.
Negative 12 times
times
2.
two.
Good. Negative 12 times 2.
8.
And vice versa, right? On those, like negative 2 times a positive 12 or negative 4 times a positive 6. Sorry. Yeah, negative 24 times 1 is an option. Lots of options, right? Which one do we want?
Negative 12. 2.
Negative 12 and the positive 2. Why do we want the negative 12 and the positive 2? Because when you check the rainbow, every time I say that phrase, check the rainbow, I just think of Skittles commercials. But that's taste the rainbow, not check the rainbow. All right. So when I check the rainbow, y times 2 is 2y. Negative 12 times y is negative 12y. And when you add those together, you get that middle term. So I know I did it correct. Okay? Letter C. Double bubble. First times first is x squared. What times what is x squared? Okay, good. And last times last has to be positive 12. What times what is positive 12?
Negative 6.
Negative 6 times negative 2. Positive 6 times positive 2. What else? 3 times 4. Negative 3 times negative 4. 1 and 12. Negative 1 and negative 12. Did we exhaust our list?
Yeah.
Did any of those work?
No.
Is this factorable?
No.
This is prime,
Fine.
not factorable.
Which one do you want to select?
Either one. It is prime. It is not composed of two parts that we can multiply together apart from itself in one. Okay? I could take out a 1, but that doesn't help me at all. Okay? All right. Last one. Double bubble. This is not the last one. There's 4 more. Sorry. What times what is x squared? X times x is x squared. Then last times last has to be negative 54y squared. What times what is negative 54y squared? That's only 54. Negative 9y
6.
Oh.
times 6y. Okay. Or?
Minus
9y negative 6.
Okay, 9y times negative 6y. Oh, good. And there's like a 2 times something, right? 27 maybe? 2 times, 2y times negative 27y. Lots of options, right? So which one do we want?
9 and the negative 6.
Positive 9y and negative 6y. Positive 9y and negative 6y. And how do you ensure that you did that correctly?
Rainbow.
Check the rainbow. I want to hear that phrase over and over. What do you get when you multiply here? 9 is 6xy, and on the inside?
Or plus
9xy. Good. And 9xy minus 6xy is 3xy. So we did it correctly. Good. All right. Raise your hand if you totally get those. Okay, good. Can you still use the block for D?
I want to see how you use the blocks.
We would have to have a different thing to represent the y squared. I can't use the same block. Okay, but I'm sure there is a way. All right. Oh dear, that must be a typo.
must be like.
I must have a typo.
For me, that was easy because I did not use that. I normally always get the biggest and chug it right before starting just to see how long it
Okay. All right. Quiet, please. That's supposed to be just 5. Know how that extra 0 got in there. All right, here we go. What's different about all these trinomials? A number in front. And a lot of students shut down when they see that there's a number in front.
Oh my God, there's so many.
Okay? So don't do that. You guys have to be super good at this. The process is exactly the same. Okay? But it's a little more of guess and check. So what times what is 5a squared? 5a times 1a, right? Okay. And there's no other options on that one, right? There's 5 is prime, so that's the only choice. Okay. And then what times what is positive 3? 3 times 1 or? Negative 3 times negative 1, right? And again, those are the only options because 3 is prime. All right. So what if I put my positive 1 and my positive 3 here? How do I know if I did it right? You're going to check the rainbow. You have to check the rainbow on these hard trinomials. Okay? Because what happens when I multiply these? It's 15a plus 1a, which would be totally wrong. Right? Okay.
Totally wrong.
So what should I do then? Switch them. Put the 3 over here and the 1 over here. So 3 on the inside, 1 on the outside. Okay. So now when I multiply, 5a times 1 is 5a. And 3 times 1a is 3a. And when we add those together, now we get the middle term. There is another method that you may know, but it's fine to use it as long as you do it right. Okay. Letter F. Double bubble. Same question. First times first has to be the first thing. What times what is 3y squared? 3y times 1y. Very good. And then last times last has to be the last thing. What times what is negative 12? Negative 4 and positive 3, or negative 3 and positive 4. Negative 2 and positive 6, negative 6 and positive 2, and 12 and 1. Lots of options here, right? What do you want to start with? Negative 3 and positive 4, I heard. Okay? So, I guess I'm going to put, what, you want to put the -3 here on the inside?
Yes.
-3 and +4. How do I know if I did it right?
Check the rainbow.
Check the rainbow. All right, and when we multiply, what do we get? 3y times 4 is 12y, and -3 times y is -3y. Did it work? No, that one did not work. If I switch them, is it going to work? No, that one doesn't work. All right, so let's try something else.
4 and 3. No, that's not. Wait.
2, -2 and 6?
Yeah.
All right, let's try that. Let's try
Oh, it's working.
-2 and 6. So if I plug in my -2 and my +6, all right, my multiply, check the rainbow. What do we get for 3y times 6? 18y. -2 times y? -2y. Does it work? Yes, it did. All right. It can be a slightly arduous process, but the more you practice, the faster you get. So I can do these in my head too, because I've been doing this for 25 years. So, okay.
Yeah. Wait, so you can look at it and know?
Usually, yeah. I mean, some of them are harder. Because when one of the terms is prime, that's really helpful. This one's composite, this one's prime. When they're both composite, it's really hard. It takes a long time. All right. Here we go. First times first has to be 6x squared. What times what is 6x squared?
2 and 3.
Oh, we got some choices, right? 2x times 3x, but also 6x times 1x. What do you want to try? 2 and 3? Okay. Can start with those. 2x times 3x. And then last times last has to be positive 5y squared. What times what is positive 5y squared? 5y times 1y. That's it, right? Or negative 5y and negative 1y. True. Okay. Okay. Do I need to worry about the negative? So let's see. I'm going to put the positive 5y and positive 1y right there. And how do I know if I did it right? Check the rainbow. 2x times 1y is 2xy. 5y times 3x is 15xy. And did we do it right?
Yes.
Yes, we did. All right. Last one. 2y squared plus 11y plus 6. Double bubble. Good. So first times first. 2y times 1y is 2y squared. Last times last has to be positive 6. What times what is positive 6? 2 times 3. Negative 6 times 1. Okay. And that's it. Those are our options, right? What do you want to try? 1 and 6?
Yeah.
Okay. That's a good thought because we have to get to 11, right? Kind of big. So,
Yeah, sorry.
let's see. What if I put a positive 6 here and a positive 1 here? What does that get you? 13, yeah. 2 times 6 is 12y plus 1y. That gets me 13. That one didn't work. If I switch them, will it work? You only get 8? All right, that didn't work. All right, so should we try the 2 and the 3?
No.
Yeah.
Just
So if I put the 2 and the 3 in and check my rainbow